Imagine standing on the edge of a vast, endless ocean, with no map, no compass, and only the sky above to guide you. For thousands of years, ancient humans faced this challenge and turned it into an art, mastering the winds, the stars, and the waves. From floating logs to double-hulled canoes, from the Nile to the Pacific, navigation shaped trade, culture, and exploration. Join me as we uncover 100 fascinating facts about ancient navigation, the skills, tools, and genius that let humanity reach across the seas long before modern technology existed. Fact 1. The earliest evidence of seafaring dates back over 50,000 years. Imagine standing on a shoreline 50,000 years ago. No compass, no charts. Just endless water stretching to the horizon. Yet, even then, some daring humans decided to leave the safety of land. They built something that could float, maybe logs tied together, or a rough raft, and pushed off into the unknown. That moment was one of the earliest sparks of exploration in human history. Archaeologists have found evidence that early people reached distant islands long before advanced tools or written language existed. Places like Australia and parts of Indonesia were settled tens of thousands of years ago, which means people must have crossed open water to get there. They weren't just drifting by accident. These journeys took planning, timing tides, reading skies, and trusting instincts shaped by experience. Picture a small group of travellers on the beach, waiting for calm weather. The ocean must have looked terrifying, deep, unpredictable, full of mystery. But curiosity was stronger. They might have studied how driftwood floated, or how birds flew out to sea and came back. Every observation mattered. Slowly they learned how to work with the sea, not against it. It's easy to underestimate how much courage that took. These weren't explorers with maps or metal tools. They were people guided by nothing but natural signs. Each voyage was a gamble. But from those risks came the first steps toward global connection, trade, migration, and the spread of ideas. Even now, modern sailors crossing the same waters still feel a quiet respect for those first navigators. Without words or technology, they began a story that still hasn't ended. The story of humanity's need to explore. Fact 2. Ancient humans likely used floating logs or primitive rafts to cross small bodies of water. Before there were ships or sails, there were trees, and someone clever enough to notice they could float. Early humans didn't build sleek boats at first. They used what nature gave them. A fallen log drifting downstream might have sparked an idea. If one log floated, what about two tied together? What if vines could hold them steady? Those simple experiments probably led to the first rafts, not designed for luxury, but for survival and discovery. They allowed people to reach nearby islands, cross rivers, or fish in deeper waters. It was small-scale travel, but revolutionary for its time. Think of it this way. A floating log might have been the first vehicle ever made. It didn't have wheels or an engine, but it changed everything. For the first time, people weren't limited by where their feet could take them. The horizon became an invitation instead of a barrier. These early raft makers would have faced challenges we can only imagine: balance, current, and weather. But every success taught them something new about buoyancy and water behaviour. And with each crossing, they grew bolder, moving from rivers to lakes to open sea channels. In a sense, those crude rafts were the ancestors of modern ships, wooden, creaky, and fragile. Yet they carried the weight of human curiosity. They proved one of the simplest truths in history. Progress often begins with a single, brave experiment. Fact 3. Early navigators followed coastlines to avoid getting lost at sea. If you've ever walked along a beach and glanced back to make sure you can still see where you started, congratulations, you've done what ancient navigators did. Following coastlines was the safest way to explore without losing direction. The land acted like a guide, a visible promise that home wasn't too far away. These early sailors weren't reckless. They understood that venturing too far from shore could mean disaster. So they hugged the coast, moving from one recognizable feature to the next, a cliff, a river mouth, or a distinctive rock formation. As they travelled, they built mental maps of the shoreline, memorizing every curve and inlet. Some journeys were seasonal. When food grew scarce, they'd sail to nearby regions, always keeping land in sight. Over time, these cautious voyages connected distant communities and laid the foundation for future trade routes. The coastline strategy also helped them learn about tides, currents, and wind directions. Every trip was a lesson, recorded not on paper, but in memory. And slowly, courage replaced caution, one bend of the shore at a time. That quiet patience is easy to overlook today, but it was genius in its simplicity. Before instruments or written charts, the coast itself was the map, and every journey along it made the world feel just a little smaller. Fact 4. The first navigational maps were mental maps based on memory and landmarks. Long before ink touched parchment, navigation happened inside the mind. Early travellers didn't have maps, they were the maps. Each landmark, a mountain peak, a certain bend in the river, the way the stars looked from a bay, became a piece of a mental puzzle they carried everywhere. Imagine setting out on a journey guided entirely by memory. You'd notice everything. The colour of the sand, the shape of clouds at sunset, even the way certain smells drifted from land. Those details became your compass. Miss one, and you might lose your way. For many ancient cultures, navigation was an art taught through storytelling and song. Routes were described in rhythm and repetition so they could be passed on easily. A chant might say, "Sail until the twin peaks rise from the horizon," and that was enough to guide someone safely home. Mental maps weren't perfect, but they were deeply personal, shaped by experience, shared through generations and constantly updated. In a world without written records, memory itself was the most reliable tool. And maybe that's the most impressive part, that humans learned to navigate vast distances with nothing but their senses and the stories they told. Fact 5. Stone Age sailors may have used the position of the sun to maintain direction. Before compasses, before charts, there was the oldest guide of all, the sun. To Stone Age sailors, it wasn't just a source of light. It was a daily clock, a dependable point of reference that helped them understand where they were headed. They likely noticed how the sun rose from one side of the sky and set on the other. Over time, they learned that its path could help them tell direction. If you were sailing at sunrise and the light was on your left, that meant you were heading north, or something close to it. This knowledge wasn't taught in classrooms. It came from observation and instinct. You can imagine them watching shadows move across the deck, noting how the sun's height changed with the seasons. Slowly, patterns emerged, a rhythm of light and motion that turned into a silent, reliable guide. Even today, sailors and hikers can still navigate this way when all else fails. That continuity, from Stone Age travellers to modern explorers, is remarkable. It reminds us that sometimes the best tools aren't the ones we invent, but the ones we notice. The sun, ever steady above the shifting waves, became humanity's first compass. Simple, silent, and unchanging. And with it, those early sailors found their way across the vast, glittering unknown. Fact 6. Ocean currents and wind patterns were observed and memorized long before written history. Long before maps, satellites, or weather forecasts, early sailors were already reading the ocean like a living thing. They didn't have words for current or trade winds, but they could feel them, the pull beneath the surface, the breath of air that always came from a certain direction. Over time, these observations became knowledge passed down by memory. Imagine a group of travellers watching the sea day after day. They'd notice how debris drifted one way, how clouds formed differently depending on the season, how the wind always shifted just before sunset. They didn't record these things with ink. They recorded them in rhythm, story, and repetition. Some ancient communities timed their voyages with the seasons, knowing that certain winds would carry them home faster, while others could trap them at sea. The sea wasn't random to them. It had patterns, moods, and cycles. They didn't fight the ocean, they partnered with it. Even now, sailors rely on the same principles. The modern trade winds and gyres are simply the names we've given to what prehistoric mariners already knew by heart. Their world may have lacked writing, but it was rich in memory, and that memory was their survival. When we look at the waves today, we might just be seeing the same movements they once trusted their lives to. The silent, steady rhythm of the world's oldest navigator, the ocean itself. Fact 7. Early migration to Australia proves advanced navigational ability in prehistoric times. Tens of thousands of years ago, long before compasses or maps, small bands of people crossed open water to reach what is now Australia. It wasn't an accident, it was one of the earliest and greatest feats of navigation in human history. Think about it. These travellers couldn't see their destination. From their shorelines, all they saw was horizon. Yet somehow they knew where to go. Archaeological evidence shows that people reached Australia around 50,000 years ago, meaning they had to cross at least 70 kilometres of open sea, even at the lowest sea levels. That's no simple drift. That's planning. They likely built rafts or canoes, timed their departures with wind patterns, and followed stars or bird migrations. They would have needed to travel together, communicate, and bring supplies, food, water, maybe even animals. That level of coordination speaks of intelligence, courage, and experience with the sea. Once they arrived, they didn't just survive, they thrived, adapting to a completely new environment. It shows that navigation wasn't just about movement, it was about migration, adaptation, and the will to explore. Today, when we talk about early explorers, these prehistoric voyagers deserve their place among the greatest. They crossed not just physical distance, but the boundary between fear and discovery, a crossing that changed human history forever. Fact 8. The first compasses were not magnetic. They were celestial or topographical. When we think of a compass, we picture a little needle pointing north. But the earliest compasses didn't use magnets at all. They were made of stars, shadows, and landscapes. Before the magnetic compass existed, travellers used what the world itself provided. At night they watched the stars. Some never moved, some rose and set. The ones that stayed fixed, like the North Star, became the first reliable directional tools. During the day, shadows told the same story. By placing a stick in the ground and watching the way its shadow shifted, early navigators could figure out where east and west lay. Even the shape of the land mattered. A certain mountain might mark the direction home. The bend of a river or the shape of a coastline could serve as a silent guide. These were topographical compasses, drawn not on paper, but in the mind. It's easy to forget how observant our ancestors were. Every sound, every change in wind or light carried meaning. Their compasses didn't fit in their hands. They existed in their awareness. And when the magnetic compass finally appeared thousands of years later, it wasn't really a new idea. It was simply a new way to express something humans had already known for ages. Direction is always there if you know where to look. Fact 9. Prehistoric sailors often used birds as guides to find land. When you're lost at sea, even the smallest clue matters. For prehistoric sailors, one of the best clues was the flight of birds. They learned that some species only flew a certain distance from shore before turning back, so if you saw birds heading in one direction at dawn, it might mean land was waiting in that direction. This wasn't just luck. It was learned through generations of observation. People noticed that seabirds like frigates or terns behaved differently when land was nearby. Sometimes they'd circle above floating debris or seaweed, another sign that land couldn't be far. In some regions, sailors even carried birds with them. When the sky looked empty for too long, they'd release one. If the bird flew straight ahead and didn't return, that was good news. If it circled back, land was still too far. It's a small, almost poetic detail, trusting a creature of the sky to find solid ground. But it worked. Birds were nature's scouts. And for early navigators, they were as valuable as any instrument. Even today, some traditional Pacific wayfinders still observe bird patterns when sailing. It's a reminder that sometimes the best technology isn't made by human hands, it's already soaring above us. Fact 10. Ancient myths. Often encoded navigational knowledge in storytelling. Before writing, before charts, the best way to preserve knowledge was through stories. And many of those ancient tales weren't just entertainment, they were teaching tools. Hidden inside them were lessons about how to travel, when to sail, and where to find land. A story about a journey across the sea might secretly describe a real route. A monster lurking in the deep could represent dangerous currents or reefs. A shining island might symbolize a place reached by following a certain star. Myths kept information alive in a world without paper, because people remembered stories better than instructions. Across cultures, oral traditions served as maps in disguise. They turned navigation into song, legend, and rhythm, things people could carry in their minds. Imagine sitting around a fire listening to an elder tell a tale of a great voyage. You think it's just a story, but every phrase hides a clue, every description points the way. By the time you're grown, you know the route by heart without ever seeing a map. These tales made sure no one forgot the paths across the sea, even when generations passed. They remind us that storytelling isn't just art. It's one of the oldest survival tools humanity ever created. Fact 11. Egyptians navigated the Nile, using current flow and seasonal winds. The Nile was Egypt's lifeline, a moving road that shaped its entire civilization. To the people who lived along its banks, navigation wasn't a luxury, it was survival. The river flowed from south to north, but the wind blew the opposite way, a perfect natural design that allowed travel in both directions. If you wanted to go north, you simply drifted with the current. Heading south? Raise a sail and let the steady north wind carry you home. It was simple, elegant, and reliable, nature's own transport system. Egyptian sailors learned to read the river like a familiar path. They knew when the water would rise, when the current would slow, and how to use sandbars and islands to rest or trade. Life along the Nile revolved around that rhythm. Grain, stone, and gold moved by boat from city to city, from temple to temple. Farmers, traders, and even builders depended on it. The river wasn't just transportation, it was a teacher, showing early navigators how to work with the flow, not against it. In a sense, the Nile was Egypt's first compass. Its steady direction gave travellers a sense of order, a way to understand their world. And from that understanding came one of history's greatest civilizations, built upon the gentle push and pull of wind and water. Fact 12. They developed early boats. Made from papyrus reeds and later wooden planks, before ships ruled the seas, Egypt had the papyrus boat, light, flexible, and surprisingly durable. Made from the same plant that became paper, these boats were woven tightly and sealed with pitch or resin. They floated high on the water and could glide effortlessly through the calm currents of the Nile. At first, papyrus boats were small, perfect for fishing or local travel. But as people began exploring farther, they needed something stronger. That's when wooden boats appeared, sturdy vessels built from acacia or imported cedar. Plank by plank, Egypt transformed from a riverbound society into a maritime one. These boats weren't just practical. They were beautifully designed. Some were carved and painted with raised prows shaped like birds or animals. Others carried cargo, soldiers, or even royal families across the Nile. Every journey on those early boats told a story of trade, of faith, of exploration. The design may seem simple by today's standards, but the principles were the same: stability, balance and trust in the craft. What began as bundles of reeds floating on a river eventually evolved into great wooden ships that sailed to foreign lands. That transformation marks one of humanity's first great leaps in technology, the moment when travel became creation and rivers became highways of progress. Fact 13. Egyptian trade expeditions reached as far as the land of Punt. Imagine a fleet of ships leaving the Egyptian shore, their sails catching the morning wind. They're headed for a mysterious place called Punt, a land spoken of with admiration and wonder. No one today can say for sure where Punt was, but ancient records describe it as a land rich in incense, gold, and exotic animals. These expeditions were massive undertakings. They required skilled shipbuilders, experienced navigators, and knowledge of the Red Sea's unpredictable waters. The journey could take weeks, even months, but the rewards were worth it. Trade with Punt brought treasures that filled temples and decorated palaces. One of the most famous voyages was led under Queen Hatshepsut's reign. Carvings in her temple at Deir el-Bahari show ships loaded with goods, trees being brought back, and the people of Punt greeting the Egyptians with gifts. It's astonishing to think that thousands of years ago, sailors were already crossing seas to trade, explore, and connect with other cultures. Those voyages proved that Egyptian navigation extended far beyond the Nile. It reached the open ocean, guided by courage, skill, and a deep respect for the waters that carried them. Fact 14. The stars were used by Egyptian sailors, especially Orion and Sirius, when night fell over the Nile. It wasn't darkness the sailors saw, it was direction. The sky was their map, and the stars their companions. Among them, two shone brighter than the rest, Orion and Sirius. Orion, with its distinct belt of 3 stars, marked the path across the heavens. Sirius, known for its dazzling brightness, rose at a time that signalled the annual flooding of the Nile. Together they served as both calendar and compass. Egyptian sailors didn't just look up for beauty, they looked up for guidance. The movement of the stars told them when to sail, how to find their bearings, and when the seasons would change. The night sky was as familiar to them as the riverbanks they followed. It's amazing to think of those quiet moments. Boats drifting in the dark, the gentle splash of oars, and above them an endless canopy of light. The stars gave direction not through instruments, but through trust and observation. Even now, when we glance at Orion or Sirius, we're seeing the same lights that once guided Egyptian sails. It's a link between their journeys and ours, proof that the oldest navigation system in the world still shines overhead every night. Fact 15. Egyptian temples, often aligned with celestial bodies, reflecting navigational awareness. If you've ever walked through an ancient Egyptian temple, you might notice something striking. The way sunlight falls perfectly into certain chambers at specific times of year. That wasn't an accident, it was precision. Egyptian builders were also sky watchers. They aligned temples, pyramids, and monuments with the rising or setting of important stars. The Temple of Amun at Karnak, for instance, aligns with the sunrise at the summer solstice. These alignments weren't only symbolic, they revealed a deep understanding of celestial patterns. This awareness came from the same mindset that guided sailors on the Nile. Both temple architects and navigators studied the heavens, observed shadows, and tracked the cycles of the sun and stars. For them, the sky was a clock, a compass, and a calendar all at once. Through these alignments, they showed how navigation wasn't limited to water. It extended to architecture, to agriculture, to life itself. The Egyptians understood that everything moved in patterns, and by studying those patterns, they could bring order to the world around them. Their temples stood as reminders that knowledge of direction, whether on land, river, or in the stars, was one of humanity's earliest and greatest arts. Fact 16. Hieroglyphs show depictions of oars, sails, and river maps. If you've ever looked closely at Egyptian hieroglyphs, you might notice something that feels surprisingly familiar: boats, oars, and even what look like maps of winding rivers. These weren't just decorations. They were records of a civilization that had already mastered one of humanity's earliest and most important skills: navigation. The Egyptians left behind some of the clearest visual evidence of how deeply river travel shaped their lives. Every carved oar and drawn sail tells a story about movement, of people, goods, and ideas flowing up and down the Nile. Imagine standing on the banks thousands of years ago, watching rows of slender reed boats glide along the water, their sails catching the afternoon breeze. Those same images were later captured in tomb paintings and stone carvings, almost like ancient travel diaries. Some hieroglyphs even show what could be considered the first river maps. These weren't maps like the ones we use today, but rather symbolic layouts of journeys, showing where to turn, where the current changed, and where important settlements were found. In a way, these images were both documentation and education, passing on vital knowledge to future generations. Through these carvings, we can see the Egyptians' understanding of the Nile as a living highway. The current flowed north, while the wind often blew south, creating a perfect natural balance. With oars and sails, sailors could move in either direction, making the Nile a two-way route, something rare in nature. These depictions also reveal how organized navigation had become, long before compasses or maps on paper. What's fascinating is how much the Egyptians combined art, record-keeping, and technology into one form. A single hieroglyphic panel could serve as both decoration and instruction. It might show which direction the boat should face during certain seasons, or how sails should be adjusted depending on the flow. To modern eyes, these details might seem small, but for ancient navigators, they were crucial survival notes. So next time you see hieroglyphs of sleek wooden ships gliding across carved waves, remember, you're not just looking at art. You're seeing a technical manual, a sailor's memory, and a cultural symbol, all in one. Fact 17. Egyptians used shadow sticks and the sun's position to determine direction. Long before magnetic compasses existed, Egyptian sailors were already using something remarkably simple, yet ingenious: shadows. Out in the desert or on the Nile, they would plant a stick in the ground and watch how the shadow moved as the day went on. The shortest shadow pointed roughly north-south at midday. Over time, this method became second nature, allowing travellers to orient themselves without any tools beyond sunlight and observation. This wasn't just theory, it was daily practice. Farmers, builders, and navigators alike relied on the same principle. The shadow stick helped them align temples, track time, and most importantly, stay on course during long journeys. Even on boats, sailors could estimate direction by the sun's height, or by noticing how the light hit the sail or deck. It's easy to forget how much patience and memory this required. You couldn't just glance at a compass. You had to feel the rhythm of the sun, and remember how it changed through the seasons. Egyptian navigators became so skilled that they could tell time and direction almost instinctively. This shadow technique was also symbolic of how Egyptians viewed balance, the harmony between light and dark, day and night, river and land. It tied navigation, agriculture, and even architecture into one continuous understanding of their environment. So while today we might rely on GPS, back then, a simple stick and a sharp eye were all it took to find your way across an empire. Fact 18. They were among the first to create organised sea trade routes in the Red Sea. When you picture ancient trade, you might think of dusty caravans and crowded markets, but the Egyptians were already looking beyond the horizons to the Red Sea. This narrow stretch of water became one of the world's earliest organised sea routes. Egyptian ships sailed from ports like Mersa Gawasis, loaded with goods, gold, incense, ivory, and exotic woods. They followed the coastline, hugging safety while exploring new lands and connecting with trading partners far beyond the desert's edge. What made these routes special was their planning. Voyages weren't random, they were mapped, timed, and repeated season after season. Crews understood the wind patterns and knew when it was safe to depart. Supplies were carefully packed, and ships were reinforced for long-distance travel. It was one of the first glimpses of global trade as we know it today. Through these expeditions, Egypt gained not only wealth, but knowledge. The sailors brought back stories, materials, and ideas. Everything from new ship designs to foreign spices. The Red Sea became a corridor of innovation, linking civilizations that might otherwise never have met. It's remarkable to think that thousands of years ago, before compasses or charts, Egyptian sailors were already managing complex maritime logistics, a sign of just how advanced their understanding of navigation had become. Fact 19. Navigation was tied to their religious and agricultural calendars. For ancient Egyptians, navigation wasn't just about finding one's way. It was woven into their entire way of life. The same observations that guided ships along the Nile also determined when to plant crops and when to hold festivals. The rising and falling of the river dictated the rhythm of society. Each year, when the Nile flooded, it brought life to the farmlands, marking the start of a new cycle. Sailors and farmers both watched the skies closely, tracking the sun and stars to predict these changes. This unity between navigation and timekeeping made Egyptian life astonishingly organised. Their calendars were among the earliest in history, built on patterns of the natural world. The appearance of certain stars like Sirius signalled important seasonal transitions, vital not only for agriculture, but also for long-distance travel. This shared system meant that captains, farmers, and priests all relied on the same observations, blending practical skill with deep respect for nature's order. Navigation, in this sense, wasn't just a profession, it was part of understanding how the world worked. Fact 20. Ancient Egyptian captains were trained to read. Both the sky and the river's behaviour, becoming a ship captain in ancient Egypt, wasn't just about steering a vessel, it was about mastering the art of reading nature itself. Captains learned to interpret the Nile's every mood, how the colour of the water hinted at the coming flood, how ripples changed with shifting winds, and how certain birds appeared when land was near. They could sense direction, even when clouds covered the sun, simply by how the current pressed against the hull. At night, they looked to the stars. Constellations like Orion and Sirius served as their silent companions, helping them keep their bearings when landmarks faded from view. The best captains were living instruments, trained through years of observation and repetition. It's said that apprentices would spend entire seasons shadowing senior navigators, memorizing routes, currents, and seasonal cues. Over time, this training turned into a profession that blended skill, intuition, and memory. So when you imagine an Egyptian ship gliding down the Nile, remember, behind that smooth movement was a lifetime of quiet study. The captains didn't just command their boats, they spoke the language of the river and sky, fluent in a world most of us have long forgotten. Fact 21. The Mesopotamians built early canals that doubled as navigational channels. When you think of Mesopotamia, you probably picture vast fields between the Tigris and Euphrates rivers, the so-called cradle of civilization. But few realize that these people were also some of the world's first engineers of navigation. The Mesopotamians didn't just rely on natural rivers, they built their own. Their canals, carved from earth and clay, weren't only for irrigation, they were highways for trade and travel. Imagine narrow, winding waterways filled with small reed boats carrying grain, pottery, and livestock between bustling city-states like Ur, Uruk, and Babylon. These canals connected entire regions, turning the once dry landscape into a living network of commerce. Merchants could move goods faster than by land, and the routes made it easier for distant settlements to stay in contact. Over time, a system of ports and storage depots formed along the banks, foreshadowing what would later become the idea of organised river transport. It's incredible to think that more than 5,000 years ago, Humans were already modifying nature not just to survive, but to travel. Every carved channel and floodgate was a mark of early navigation, a way to move through the world with purpose. So while the canals might look simple today, they were once the arteries of civilization, carrying both water and the first stirrings of exploration. Fact 22. Clay tablets suggest they had a concept of cardinal directions. Among the thousands of clay tablets discovered in Mesopotamia, a few reveal something extraordinary. The first recorded hints that people understood the idea of north, south, east, and west. These tablets weren't just random drawings. Some were maps, showing rivers, cities, and roads carefully etched into wet clay. And alongside those drawings were words or symbols suggesting direction, proving that even at that early stage humans were trying to make sense of spatial orientation. For Mesopotamian travellers and traders, direction was everything. They used the rising and setting of the sun to find east and west, and the flow of the Tigris and Euphrates helped define north and south. These natural cues became part of their vocabulary, guiding them through vast plains where landmarks were scarce. This system wasn't just about travel, it also shaped their architecture and city planning. Temples and streets were often aligned along these cardinal lines, blending practical orientation with symbolic meaning. So when you picture a Mesopotamian scribe pressing his stylus into a clay tablet, remember, he wasn't only recording information, he was helping define the very concept of direction, a breakthrough that would guide humanity for millennia to come. Fact 23. The Phoenicians are considered the greatest ancient seafarers of the Mediterranean. If there was ever a civilization born for the sea, it was the Phoenicians. These people, living along the coast of what is now Lebanon, didn't just sail. They conquered the Mediterranean through skill, trade, and daring exploration. Their cities, like Tyre and Sidon, were filled with shipbuilders who turned cedar wood into some of the most advanced vessels of their time. While others hugged coastlines, the Phoenicians pushed outward, venturing far beyond familiar waters. They founded colonies across North Africa, Spain, and even as far as the Atlantic coasts. What made them special wasn't just bravery, it was organisation. They developed regular trade routes, carrying purple dye, glass and timber across thousands of miles. Their ships were fast, reliable, and designed to handle open seas. To the Phoenicians, the Mediterranean wasn't a barrier, it was a bridge. Every wave carried opportunity, and every horizon promised connection. Their expertise turned them into the world's first true maritime empire, one built not by armies, but by sailors, traders, and navigators who trusted their instincts and the sea. Fact 24. Phoenician ships could travel from the Mediterranean to Britain for tin. Now imagine this. Nearly 3,000 years ago, long before compasses and charts, Phoenician ships sailed all the way from the Mediterranean to the British Isles in search of tin. That metal, vital for making bronze, was a treasure of its time. The journey was no small feat. It meant navigating through the dangerous Strait of Gibraltar, venturing into the rough Atlantic and following coastlines for weeks under unpredictable weather. Historians believe these expeditions reached as far as Cornwall, where ancient tin mines once stood. The fact that the Phoenicians could complete such voyages speaks volumes about their skill. They read the winds, studied the stars, and remembered every curve of the coastline. The journey back was equally challenging, but their reward was immense. Tin was so valuable that it fueled entire economies and trade networks, and each voyage expanded their knowledge of the wider world, connecting distant lands long before global maps existed. In a sense, those Phoenician ships weren't just carrying cargo, they were carrying the spark of global navigation. Fact 25. They navigated. Using the North Star, known as the Phoenician Star. When night fell over the open sea, the Phoenicians didn't panic. They looked up. There, shining steadily above the horizon, was their most trusted companion, the North Star. They called it the Phoenician star, and for good reason. While others feared drifting too far from shore, these sailors realized that this one bright light never seemed to move. By aligning their ships to it, they could maintain direction even in total darkness. This discovery changed everything. It allowed longer voyages, more confidence in open waters, and the birth of true nighttime navigation. To think that thousands of years ago sailors stood on wooden decks, waves crashing around them, guided only by that single star, it's humbling. Their courage, skill, and quiet trust in the sky laid the foundation for all future exploration. So next time you see the North Star twinkling overhead, remember, it once had another name, whispered by sailors who dared to follow it into the unknown. Fact 26. Phoenicians possibly circumnavigated Africa under Pharaoh Necho. It sounds almost unbelievable, doesn't it? Thousands of years ago, long before the age of exploration, a fleet of Phoenician sailors may have sailed all the way around Africa. According to ancient records, Pharaoh Necho, the second of Egypt, commissioned this daring voyage around 6 centuries before the Common Era. He wanted to know just how vast the African continent was. The job fell to the Phoenicians, the most skilled sailors of their time. They set out through the Red Sea, hugging the coastline, and sailed south for months. Each year they stopped to grow crops, harvest food, and repair their ships before continuing. After nearly 3 years, they emerged again through the Strait of Gibraltar, having circled the entire continent. The most convincing detail? The sailors reported that at one point the sun was on their right-hand side while sailing west, a fact that only makes sense if they had crossed the southern hemisphere, where the sun appears in the northern sky. Even if the full voyage remains debated, the story shows just how fearless the Phoenicians were. Whether they truly made it or not, they were the kind of navigators who would have tried, and that courage alone set them apart. Fact 27. They used dead reckoning to estimate distance and direction. Long before modern instruments or maps, Phoenician sailors relied on something surprisingly mathematical, a method called dead reckoning. Here's how it worked. Once a ship set out, the crew constantly estimated their direction, speed, and time travelled. By combining those 3 pieces of information, they could roughly calculate how far they had gone and where they might be. No compass, no GPS, just pure observation, memory, and skill. They'd feel the strength of the wind, study how fast waves passed the hull, and measure time using simple tools or even the rhythm of rowing. Then, using those clues, they'd adjust their course. Of course, it wasn't perfect. One mistake in calculation could send a ship miles off course. But for the Phoenicians, who repeated the same trade routes over and over, dead reckoning became second nature. It was a mental map constantly updated in motion. Every successful voyage was proof of their mastery. They turned the act of sailing, unpredictable and dangerous, into something almost scientific. Fact 28. The colour of the sea and smell of air were cues for nearing land. Imagine being days at sea. No land in sight, no instruments to guide you. For Phoenician sailors, hope often came from the senses, particularly sight and smell. They noticed that the colour of the water changed as they approached land. Near shorelines, the sea shifted from deep blue to a lighter, greener hue. Floating bits of plants or driftwood were clues that rivers or islands weren't far away. But even more subtle was the smell. Land has a scent, earthy, warm, sometimes mixed with vegetation or smoke from distant fires. Experienced sailors could catch that scent before the coastline even appeared. Seabirds were another signal. If they flew overhead in the morning and returned by evening, it meant land was nearby. These natural signs became their compass. The Phoenicians didn't just observe nature, they listened to it. Their survival depended on noticing what others might overlook. It's remarkable to think how the ocean spoke to them, not in words or symbols, but in colours, breezes, and faint scents carried over the waves. Fact 29. Phoenicians traded purple dye, wood and glass, requiring expert maritime routes. The Phoenicians weren't just sailors, they were entrepreneurs of the ancient world. Their ships carried goods that were so valuable. Other civilizations built entire economies around them. Foremost was the famous purple dye, made from tiny sea snails along the Phoenician coast. It was incredibly rare, so rare that it became a symbol of status across empires. Alongside it came cedar wood, prized for its strength, and delicate glassware, an invention the Phoenicians helped perfect. Transporting these fragile and costly items wasn't easy. Routes had to be precise, predictable, and safe. A single storm could ruin fortunes, so their navigators became experts at reading seasonal winds, memorizing reefs, and timing departures with uncanny accuracy. The trade network they built stretched from the eastern Mediterranean to the Atlantic, a maritime web connecting cultures long before global commerce existed. Each voyage carried more than cargo, it carried connection. The Phoenicians weren't just selling goods, they were spreading knowledge, language, and innovation across the sea. Fact 30. They established lighthouse beacons on coasts for nighttime navigation. Picture this: a dark shoreline, waves crashing against rocks, and a lone flame flickering high on a cliff. That light, seen from miles away, could mean safety, the sign of home, or a friendly port. The Phoenicians are believed to have built some of the earliest lighthouse beacons, using tall towers or fires placed on hills near their harbours. These early beacons helped sailors find their way back after sunset, especially when returning from long trade journeys. Some ports even had distinctive flame patterns, brighter, dimmer, or higher, so ships could tell which city they were nearing. It was a primitive but effective form of coastal communication. These lighthouses weren't grand stone towers like those that came later in Greece or Rome. They were simple, often wood, clay, or stone structures, but their impact was enormous. They turned night sailing from pure risk into possibility. And in that soft glow across the waves, you can almost imagine a Phoenician captain steering homeward, guided not by stars this time, but by the light of his own people waiting on shore. Fact 31. Greeks were among the first to write about navigation. Scientifically, for centuries sailors had relied on instinct and observation. Then came the Greeks, and they decided to study the sea. While earlier civilizations like the Egyptians and Phoenicians mastered practical navigation, the Greeks began asking why the winds blew, how the stars moved, and what shaped the Earth's geography. They were among the first to treat navigation as a science, something that could be observed, measured, and written down. Greek thinkers such as Thales, Anaximander, and later Eratosthenes didn't just record what sailors knew. They turned it into a structured system of knowledge. They drew maps, analysed wind patterns, and even discussed the curvature of the Earth long before anyone could prove it. Ports like Miletus and Corinth became centres of learning where trade, exploration, and science overlapped. Sailors, astronomers, and philosophers often shared the same questions. What lies beyond the horizon, and how can we find our way there safely? The Greeks' curiosity transformed navigation from survival into understanding. It was no longer just about reaching a destination. It was about knowing why the journey worked. That mindset would shape exploration for centuries to come. Fact 32. Pytheas of Massalia sailed to the Arctic Circle, using the sun's height to measure latitude. Around the 4th century before the Common Era, a Greek explorer named Pytheas of Massalia, modern-day Marseille, embarked on one of the boldest voyages in ancient history. He sailed beyond the familiar world, past the Pillars of Hercules, the Strait of Gibraltar, up along the Atlantic coasts and into the icy northern seas. His goal? To understand how far north the world extended. What made Pytheas remarkable wasn't just his courage, it was his method. He used the sun's height at noon to estimate latitude, marking one of the earliest known attempts at scientific navigation. By measuring shadows, he could determine how far north he had travelled, even without landmarks or maps. He eventually reached a mysterious land he called Thule, which some historians believe may have been Iceland, Norway, or even the Arctic Circle. Pytheas described floating ice, endless summer daylight, and the strange rhythm of northern tides, observations that would later prove astonishingly accurate. His journey wasn't just exploration, it was data collection. Pytheas proved that careful observation could turn the unknown into knowledge, one shadow, one measurement, one wave at a time. Fact 33. Ancient Greeks created some of the earliest star charts. The night sky was both a mystery and a map to the ancient Greeks. While earlier civilizations had named constellations, the Greeks began systematically charting them, turning scattered stars into tools for travel. Astronomers like Eudoxus of Cnisis and later Hipparchus recorded the positions of stars, describing how they rose and set in relation to Earth's horizon. These records became some of the earliest star charts, visual guides that allowed sailors to navigate by constellations instead of just guessing direction. Constellations like Ursa Major, the Great Bear, and Orion weren't just mythic figures, they were signposts. Sailors used them to determine north, locate seasons, and estimate their latitude by how high certain stars appeared in the sky. The Greeks' precision was remarkable. By combining geometry with observation, they laid the foundation for celestial navigation, the very system that would one day guide explorers across oceans. So, when we look up at the stars today, tracing patterns that feel ancient and familiar, we're still following a map drawn thousands of years ago by curious minds who dared to measure the heavens. Fact 34. The concept of latitude came from Greek astronomy. It's easy to take the idea of latitude for granted, those neat horizontal lines across every modern map. But that concept has deep Greek roots. Greek astronomers noticed that the height of the sun and certain stars changed depending on how far north or south one travelled. From this, they developed the idea of dividing Earth into horizontal zones, each with its own climate and celestial angle. Eratosthenes, one of the great thinkers of Alexandria, took it even further. By comparing the sun's shadow in two cities at the same time, he not only measured latitude, he calculated the Earth's circumference with astonishing accuracy. For sailors, this concept was revolutionary. It meant that travel could be described not just as far or near, but in measurable degrees. Navigation was no longer limited to instinct, it was becoming mathematical. In a world still uncertain about the planet's shape, Greek astronomy quietly introduced one of the most powerful tools in exploration, the ability to know where you are on a sphere. Fact 35. Aristotle documented ocean currents and wind systems. Before modern meteorology, Aristotle was already studying how the air and sea moved. In his work, Meteorologica, he described patterns of winds, tides, and ocean currents, trying to explain why they change with the seasons. He noticed that warm air rose while cool air sank, forming wind systems that affected sailing routes. He also observed that certain currents seemed to follow predictable paths, which helped sailors plan safer journeys. While his explanations weren't always perfect, his curiosity laid the foundation for environmental observation. Aristotle understood that navigation wasn't just about the stars above, it was also about the forces below, the invisible rhythms of air and water. What's striking is how he connected everything: geography, climate, and movement. For him, the sea was alive, its behaviour shaped by natural balance rather than chance. In that sense, Aristotle didn't just document navigation, he helped turn it into a study of nature itself, the beginning of our long relationship with understanding how the planet truly moves. Fact 36. Romans inherited and expanded Greek navigational knowledge. When the Romans rose to power, they didn't start from scratch. They inherited a world already charted, measured, and observed by the Greeks, and then turned that knowledge into a practical empire of sea routes. Greek astronomers had mapped the stars, measured latitude, and studied winds. The Romans took those ideas and built a network of ports, shipping routes, and naval bases that spanned from Britain to Egypt. Navigation became not just a science, but a state operation, essential for trade, military control, and communication across the Mediterranean. Roman sailors were trained to use celestial observations, coastal landmarks, and seasonal wind patterns. They blended theory and practice, much like modern mariners. And while the Greeks had loved exploration for the sake of discovery, the Romans valued it for what it could build: connection, commerce, and control. You can almost picture it. Sturdy Roman cargo ships loaded with grain, wine, and marble, guided by knowledge born centuries earlier in Greek classrooms. The Romans didn't just borrow navigation, they industrialized it. They turned knowledge into empire. Fact 37. Roman sailors used portolan charts for coastal navigation. Imagine a hand-drawn map filled with lines radiating from compass points, showing harbours, bays, and rocky shorelines. That's a portolan chart, the GPS of the ancient Mediterranean. Roman sailors relied on these early maps to travel safely from port to port. Unlike abstract world maps, portolan charts were practical. They showed where to dock, where to avoid reefs, and which direction to steer based on prevailing winds. Each line, or rhumb, helped sailors maintain a course between known landmarks. These charts likely evolved from the Greeks' coastal itineraries, but were refined by Roman ship captains who needed accuracy for military and trade voyages. Of course, they weren't perfect. Storms, shifting sands, or human error could still cause disaster. But compared to sailing blind, portolan charts were revolutionary. They turned coastlines into readable information, transforming the unpredictable sea into a network of reliable paths. In many ways, those hand-drawn maps were the ancestors of modern nautical charts, living proof that even 2,000 years ago, sailors were already learning to make sense of the sea on paper. Fact 38. The Greeks invented the gnomon, a shadow, measuring device used for direction. Long before compasses existed, a simple stick changed the way people understood direction and time. The gnomon, a vertical rod used to measure shadows, was a Greek invention that guided explorers, builders, and astronomers alike. At its simplest, it worked like this. You place the stick upright, observe the shadow, and notice how it moves as the sun travels across the sky. The shortest shadow at noon pointed south, and from there you could find north, east, and west. This tool wasn't just useful for sailors, it was the foundation for sundials, early astronomy, and even architecture. Temples, roads, and cities were often aligned using gnomon measurements. For navigation, it became a portable compass powered by the sun. Greek sailors could orient themselves on land or sea by comparing the shadow's length and direction throughout the day. It's astonishing how such a simple object could unlock such powerful knowledge, showing once again that in the ancient world, innovation often began with curiosity and observation, rather than complex machines. Fact 39. The Lighthouse of Alexandria. Served as a navigational wonder of the world, few ancient structures captured the imagination like the Lighthouse of Alexandria, built on the small island of Pharos around the 3rd century before the Common Era. Standing more than 300 feet tall, it was one of the 7 wonders of the ancient world, and the greatest symbol of navigation ever built. Its light, created by a massive open flame reflected through polished bronze mirrors, could reportedly be seen for miles across the sea. For sailors approaching Egypt's busy harbour, that glow meant safety, the sign that they had reached civilization after weeks of open water. But the lighthouse wasn't just practical, it was inspirational. It represented humanity's determination to overcome darkness, to make sense of the vast unknown. Engineers of the time studied its design for generations, copying its tiered structure in later towers and fortresses. Even centuries after it collapsed, The lighthouse of Alexandria remained a symbol of guidance and innovation. It stood as proof that navigation wasn't only about science, it was also about hope, the light that led sailors home. Fact 40. Roman sailors navigated primarily during daylight and fair weather. Despite all their progress, Roman sailors still respected one truth: the sea was not to be taken lightly. Most voyages took place only during daylight and in the calmer months of the year, roughly from March to October. Without compasses, accurate clocks, or advanced maps, sailing at night or through storms was incredibly risky. The Romans preferred to anchor at dusk and wait for sunrise, using visible landmarks and stars only when absolutely necessary. Even military fleets, efficient as they were, often waited for the right wind and season before setting sail. Ancient captains studied weather patterns carefully. A wrong choice could mean disaster. It wasn't fear, it was wisdom. They understood the limits of their tools and trusted their instincts more than anything. Still, that didn't stop them from pushing boundaries. Over time, Roman sailors began to take cautious night voyages, especially along well-known routes. Every successful journey, every safe return, slowly expanded the confidence and skill that would later inspire a new generation of explorers. By respecting the sea, the Romans ensured that their empire stayed connected, proof that good navigation isn't just about courage, but also about knowing when to wait for the wind. Fact 41. Ancient Indian sailors mastered monsoon wind navigation. Long before the age of global exploration, Indian sailors had already learned to read the language of the winds. The monsoon system, seasonal winds that shift direction twice a year, became the heartbeat of ancient Indian navigation. By understanding these cycles, sailors could travel thousands of miles safely and efficiently. The southwest monsoon, blowing from the Indian Ocean toward the subcontinent, brought ships home from distant lands. The northeast monsoon, moving in the opposite direction, carried them outward, toward Arabia, East Africa, and Southeast Asia. This predictable rhythm turned the Indian Ocean into a navigational highway. Captains timed their voyages around these winds, using them to propel large wooden vessels loaded with spices, textiles, and ivory. Ports like Lothal, Muziris, and Baharush flourished as centres of trade and learning. What made this knowledge so remarkable was its precision. Sailors knew not only when the winds would shift, but also how temperature, cloud patterns, and even the smell of the sea could signal a coming change. Their understanding of nature was as accurate as any modern forecast, earned through centuries of close observation. By mastering the monsoon, ancient Indian mariners didn't just survive the seas, they built one of the earliest international trade networks in history. Fact 42. The Harappan civilization had active maritime trade with Mesopotamia. The Harappan or Indus Valley civilization, thriving over 4,000 years ago, wasn't an isolated culture. Archaeological evidence reveals that it maintained vibrant trade connections and some of the earliest maritime links with Mesopotamia, hundreds of miles to the west. Seals and artifacts found in Mesopotamian cities bear unmistakable Harappan symbols, while Mesopotamian texts mention a distant land called Meluha, believed to refer to the Indus region. Ships likely carried carnelian beads, lapis lazuli, textiles, and metalwork from Harappan ports to Mesopotamian markets. The port city of Lothal, located in modern-day Gujarat, was a masterpiece of early engineering, featuring a dockyard, warehouse, and drainage system. Its carefully designed basin could hold ships safely during the tidal shifts of the Gulf of Khambat. This wasn't a coincidence, it was advanced planning. The Harappans clearly understood tides, currents, and seasonal winds, allowing them to trade across long distances with consistency. Their maritime routes laid the foundation for centuries of Indian Ocean commerce. In a time when many civilizations barely ventured beyond their rivers, the Harappans had already turned the sea into a bridge between worlds. Fact 43. Indian mariners used constellations like Canopus for orientation. Before magnetic compasses, sailors looked to the heavens, and Indian mariners were among the most skilled celestial navigators of the ancient world. One of their key stars was Canopus, known locally as Agastya. Visible in southern skies, Canopus became a crucial guide for navigation in the Indian Ocean. When it rose above the horizon, sailors knew they were far enough south to approach the equatorial waters. The star helped orient travellers moving towards Sri Lanka, Indonesia, and beyond. Indian navigators also tracked constellations like Ursa Major and the Pleiades, along with the steady rhythm of the sun and moon. These celestial cues work together with their deep knowledge of winds and currents to chart safe paths across open water. The study of these stars wasn't just practical, it was systematic. Ancient Indian texts such as the Surya Siddhanta describe the motion of celestial bodies with remarkable accuracy. By combining astronomy with seafaring, Indian sailors achieved a rare balance of science and instinct. The night sky became their compass, and every journey was guided by a dialogue between sea and stars. Fact 44. Tamil seafarers reached Southeast Asia, centuries before European exploration. Long before European ships ever reached the east, Tamil sailors from southern India had already established thriving maritime routes across Southeast Asia. From as early as the 3rd century before the Common Era, Tamil kingdoms like the Cholas, Pandyas and Cheras sent fleets across the Bay of Bengal. Their voyages connected India to present-day Malaysia, Indonesia, Thailand, and even parts of China. These weren't short trips, they were full-scale cultural and economic exchanges. Tamil merchants exported textiles, spices and pearls, while importing gold, tin and exotic woods. Ports like Kavaripattinam and Nagapattinam bustled with activity, serving as international hubs where sailors shared not only goods but knowledge of languages, tides and trade winds. Evidence of this contact appears in Southeast Asian inscriptions, coins and architecture that bear Tamil influence. Some local scripts and place names even trace their roots to Tamil trade settlements. The scale and consistency of these voyages prove just how advanced Tamil seamanship was. They built large, seaworthy vessels, studied the stars and followed the monsoon cycles, techniques that would later inspire other Indian Ocean navigators. Centuries before the first European explorers, Tamil sailors had already made the world smaller. Fact 45. The compass was known in ancient India as the Matsya Yantra. Long before the compass became a common tool of navigation, Indian mariners were familiar with a device called the Matsya Yantra, meaning fish instrument. References to it appear in early Indian maritime traditions and later scientific texts, suggesting a method of orientation long before magnetic compasses spread from China. Descriptions of the Matsya Yantra vary. Some accounts describe a floating piece of iron shaped like a fish that aligned itself along the north-south axis when placed on water, remarkably similar to how magnetic compasses would later function. Whether used on ships or during land expeditions, this instrument allowed travellers to maintain a consistent direction even under cloudy skies or when stars weren't visible. Combined with their knowledge of celestial navigation and monsoon patterns, the Matsya Yantra gave Indian sailors an extraordinary advantage in long-distance voyages. It's a testament to how ancient mariners sought constant improvement, blending natural observation with early technology. While many civilizations still feared the open sea, Indian sailors had already learned to master it through intelligence, precision, and innovation. Fact 46. Ancient Sanskrit texts describe shipbuilding and maritime travel. If you leaf through the pages of ancient Sanskrit literature, you'll find more than just poetry and philosophy. You'll find a surprising amount of practical knowledge about the sea. Texts like the Yuktikalpataru, Brihat Samhita, and Arthashastra contain detailed descriptions of shipbuilding, navigation, and ocean trade. They talk about how ships were designed for strength and stability, with instructions for choosing timber, shaping the hull, and sealing joints with natural resins. Some passages even categorise ships by purpose, those for rivers, coastal trade, and long ocean voyages. It's clear that maritime life wasn't an afterthought in early India, it was central to its identity. Sanskrit verses mention ports, harbours, and ocean routes, describing the sea as both a challenge and an opportunity. One fascinating insight from these texts is the care given to safety and precision. Ship captains, or navika, were trained not only in steering but in reading winds, waves, and stars. They relied on experience and science, an early example of applied navigation long before modern instruments. Far from being landlocked thinkers, these writers celebrated seafaring as a noble and skilled art, one that connected India to the wider world. Fact 47. Early Indians developed the concept of nakshatra, lunar mansion, for navigation. Imagine sailing beneath a dark sky, guided only by the faint shimmer of stars. That was reality for ancient Indian sailors. And to navigate, they created a brilliant system based on the nakshatras, or lunar mansions. The sky was divided into 27 or 28 sections, each marked by a particular star or constellation that the moon passed through during its monthly journey. These nakshatras acted like celestial signposts. By knowing which nakshatra the moon was in, sailors could tell both the time of the month and their approximate direction. This system was deeply mathematical. Indian astronomers mapped the stars with impressive accuracy, calculating their positions and movements centuries before the invention of telescopes. Sailors used this knowledge to plan departures, track their location, and estimate when monsoon winds would shift. What's most striking is how seamlessly this knowledge blended observation with application. The nakshatra system was not only spiritual or symbolic, it was practical science, used to cross vast stretches of sea safely. In an age when the open ocean was a mystery, Indian sailors looked up and turned the night sky into a living compass. Fact 48. They traded spices, gems, and silk across vast ocean routes. Picture the scent of cinnamon, the glint of sapphire, and the shimmer of silk. These were the treasures that flowed from India's ports to the rest of the ancient world. Indian merchants commanded some of the busiest sea routes in history, connecting East Africa, Arabia, Southeast Asia, and even the Mediterranean. Ships loaded with pepper, cardamom, pearls, ivory, and fine cotton set sail from ports like Muziris, Kavrapattinam, and Baragaza. In return, they brought back gold, wine, coral, and horses. Each voyage carried not just goods, but stories of cultures meeting, languages mixing, and technologies blending. This trade didn't happen by chance. Indian navigators timed their departures with the monsoon winds, ensuring smooth sailing both ways. They studied ocean currents, memorized landmarks, and followed constellations that led them safely back to their home ports. The sheer scale of this commerce speaks volumes. Long before global trade became a modern concept, India was already at the centre of a maritime network that tied continents together, powered by courage, skill, and centuries of accumulated wisdom. Fact 49. Indian navigators mapped coastlines, using time, distance, and star elevation. Before compasses and charts, sailors relied on experience, but Indian navigators turned that experience into measurable science. They developed a method of mapping coastlines by combining time, distance, and the elevation of stars above the horizon. By observing how high a certain star appeared at night, sailors could estimate their latitude. They measured distance not in miles but in time, how long it took to travel from one known landmark to another under specific wind conditions. It was a system built on observation and rhythm. The sea had its own patterns, and Indian sailors learned to read them with near-perfect accuracy. This knowledge was passed down through generations, refined by practice rather than written maps. Eventually, these techniques allowed them to create early coastal charts, mental or drawn, that showed safe harbours, dangerous reefs and landmarks visible from the sea. Their maps may not have looked like modern ones, but they worked beautifully, guiding sailors across thousands of miles without losing their way. It was navigation as both science and art, guided by intuition and the stars. Fact 50. The Indian Ocean was a crossroads for African, Arab and Asian navigation systems. For thousands of years, the Indian Ocean wasn't a barrier, it was a meeting place. Sailors from India, Arabia, Africa and Southeast Asia shared its waters, exchanging not only goods but knowledge. Indian mariners taught others how to use monsoon winds and celestial navigation. Arab sailors contributed their own innovations, like the kamal, a small device for measuring star altitude. African navigators shared coastal routes and weather patterns. This collaboration transformed the Indian Ocean into one of history's most interconnected regions. Ports like Aden, Calicut and Zanzibar became melting pots of languages and ideas, places where merchants, mapmakers and sailors compared techniques and improved together. Over time, these shared practices laid the groundwork for future exploration and trade routes that would shape global history. The Indian Ocean didn't belong to any one culture. It belonged to all who dared to understand it. In its winds, waves and stars, the navigators of the ancient world found common ground, and in doing so they connected continents long before modern maps ever existed. Fact 51. The Chinese were among the first to use a magnetic compass. Long before the great voyages of European exploration, Chinese inventors had already discovered one of the most important tools in human history, the magnetic compass. It changed everything about how people travelled, traded and explored the world. Originally, the compass wasn't even made for navigation. Early Chinese scholars created it to align buildings and tombs, according to the principles of harmony and balance. But somewhere along the way, someone realised that if it could point north on land, it could also guide a ship across the endless sea. By the 11th century, Chinese sailors were using compasses on their voyages, transforming how they navigated open waters. No longer did they have to rely solely on the stars or coastline. Now, they could travel even when the sky was cloudy or the shore was out of sight. This quiet innovation spread gradually across Asia and eventually to the rest of the world. Without the Chinese magnetic compass, many of the great maritime discoveries we know today might never have been possible. It's remarkable to think that such a simple instrument, a needle pointing north, reshaped the course of navigation and global history. Fact 52. The earliest Chinese compass used a lodestone floating in water. Before compasses became small metal instruments, the earliest Chinese navigators used lodestone, a naturally magnetized mineral. These early devices were simple but brilliant, a piece of lodestone carved into the shape of a spoon, floating on water or placed on a smooth bronze plate. The handle of the spoon would always point south, providing an early reference for direction. It wasn't perfect, but it worked, a discovery that came centuries before most of the world even understood magnetism. At first, these tools were used for divination and city planning, but it didn't take long for their practical potential to be noticed. Over time, engineers refined the design, creating suspended needles that could move freely and point more accurately. Eventually, sailors learned to protect these delicate devices from the ship's motion by enclosing them in boxes filled with water or oil. From that simple lodestone floating in a bowl grew the sophisticated compass technology that guided fleets across oceans. It was an elegant example of how observation and curiosity could turn a natural phenomenon into a tool that shaped human exploration forever. Fact 53. Han Dynasty. Explorers mapped the South China Sea and beyond. During the Han Dynasty, roughly 2,000 years ago, China's explorers were already pushing far beyond their own shores. Their voyages into the South China Sea marked the beginning of a deep maritime tradition that would last for centuries. These early navigators charted islands, measured coastlines, and recorded wind patterns, building a growing knowledge of the ocean's geography. Evidence suggests they traded with regions as distant as Southeast Asia, India, and even parts of Arabia. The Han government encouraged exploration not just for curiosity but for trade and diplomacy. Silk, ceramics, and precious metals became valuable exports, while spices and exotic goods flowed into Chinese ports in return. What made these journeys so impressive was their accuracy. Without modern instruments, sailors used the sun, stars, and, later, magnetic compasses to maintain direction. They created some of the earliest maritime maps, paving the way for future dynasties to expand China's reach across the seas. By the end of the Han period, China had become not only a land empire, but also a growing maritime power, one that understood the ocean not as a boundary but as a bridge. Fact 54. The Chinese linked feng shui principles to directional science. In ancient China, the study of direction wasn't just about navigation. It was part of a much larger philosophy known as feng shui, meaning wind and water. At its heart, feng shui was about harmony, aligning human life with the natural world through orientation, space, and balance. But beneath the philosophy lay a keen scientific understanding of geography and direction. Chinese thinkers observed how mountains, rivers, and winds interacted with the land and developed precise methods for positioning buildings, cities, and tombs. This emphasis on direction led directly to innovations in magnetic study. The same instruments used to find the most favourable building alignment also revealed consistent north-south orientation, an observation that inspired the creation of the magnetic compass. It's fascinating how something spiritual in nature eventually sparked one of the most practical tools in human history. For the Chinese, understanding direction wasn't just about where to go, it was about living in balance with the world around them. And in that balance, they found the path to discovery. Fact 55. During the Song dynasty, compass-based sea charts became common. By the time of the Song dynasty, roughly 1,000 years ago, Chinese sailors had fully mastered the use of the magnetic compass. It wasn't just an experimental tool anymore, it had become an everyday instrument of navigation. With this advancement came another innovation: compass-based sea charts, known as navigation maps of the sea routes. These charts combined compass bearings with distances between ports, creating a new kind of navigational record that no longer depended solely on memory or visible landmarks. Sailors could now follow recorded headings across open water, allowing safer, longer voyages. The Song dynasty's maritime fleet grew rapidly, connecting China with the Philippines, Indonesia, India, and the Persian Gulf. What's most remarkable is how these charts mark the beginning of systematic ocean navigation. For the first time, a sailor could plot a course not by instinct, but by data, direction, distance, and observation working together. These innovations turned China into one of the leading maritime powers of the medieval world and laid the groundwork for global exploration centuries later. The Song sailors didn't just follow the stars, they created a map of their own, guided by a compass needle that always knew the way home. Fact 56. Chinese sailors recorded latitude, using pole star measurements. For ancient Chinese sailors, the night sky wasn't just a source of wonder, it was a working instrument. Long before telescopes or sextants existed, they had already learned to use the pole star or Beiji Xing to calculate latitude and direction with impressive accuracy. The pole star, nearly fixed in the northern sky, became a reliable guide. By measuring its height above the horizon, sailors could determine how far north or south they were. A lower angle meant they had travelled south, a higher one meant they were sailing north. Chinese navigators often used simple yet clever devices for this, like a wooden board or string to estimate the star's elevation. This practical system allowed them to keep precise track of their routes, even across vast stretches of open ocean. Combined with compass bearings and wind knowledge, These star-based calculations made Chinese navigation both mathematical and intuitive. It was science shaped by centuries of observation, and it worked astonishingly well. By trusting the sky, Chinese sailors could find their place on Earth long before anyone else drew lines of latitude on a map. Fact 57. Zheng He's voyages demonstrated mastery of long-distance ocean navigation. When you think about great explorers, few can match the scale of Zheng He's voyages during the early 15th century. His fleets, known as the treasure voyages, were so vast and advanced that they remained one of the most impressive feats of navigation in human history. Zheng He commanded hundreds of ships and tens of thousands of sailors, sailing from China to Southeast Asia, India, Arabia and East Africa, all without modern instruments. His fleet's largest ships, called baoxuan, were said to reach over 120 metres in length, equipped with multiple decks, watertight hulls and advanced rudder systems. But what truly set these journeys apart was their precision. Zheng He's navigators used magnetic compasses, star charts, and detailed maritime handbooks that described every current and coastal landmark. They recorded monsoon patterns meticulously, allowing them to return home with reliability and speed. These voyages weren't about conquest. They were about knowledge, trade, and diplomacy. They proved that by the early 15th century, China had reached a level of ocean mastery that wouldn't be matched in scale for centuries. Zheng He's ships didn't just cross the ocean, they connected civilizations, setting a standard for navigation that would inspire generations of sailors worldwide. Fact 58. Chinese junk ships had sophisticated rudders and watertight compartments. Among the many innovations that made Chinese navigation legendary, few were as brilliant as the junk ship, a design so advanced that its influence can still be seen in modern shipbuilding today. Junk ships featured large, adjustable rudders mounted on the stern, giving sailors unmatched control even in rough seas. This design allowed for precise steering and smoother handling during long voyages, something many early Western ships struggled to achieve. Equally impressive were the watertight compartments built inside the hull. These acted like modern bulkheads. If one section was damaged or flooded, the others stayed sealed, keeping the vessel afloat. This engineering breakthrough gave Chinese sailors incredible confidence to venture across the unpredictable Indian Ocean and beyond. The sails, made of bamboo and cloth, could be raised or lowered easily, allowing ships to catch or resist the wind as needed. Every feature reflected centuries of refinement, a perfect blend of strength, flexibility, and safety. When foreign traders first saw these ships, they were astonished. The Chinese junk wasn't just a vessel, it was proof of a civilization that understood both the sea's beauty and its dangers, and engineered a masterpiece to conquer both. Fact 59. Chinese navigators used cloud colour and seaweed as indicators of land proximity. Before radar and radio, sailors relied on nature itself as their guide, and Chinese navigators were masters at reading its signs. Among their most reliable clues for finding land were cloud colour and floating seaweed. They noticed that clouds often formed and behaved differently over land than over open sea. For example, tall, stationary clouds tended to gather above islands or coastlines, while drifting clouds signalled open water. The colour of the clouds also changed, with a faint yellow or green tint hinting at nearby land. Seaweed offered another subtle hint. When sailors began to notice more floating vegetation, they knew they were nearing shallower waters or coastal regions where plants could thrive. Birds, too, became part of this natural navigation system. Their flight direction often revealed where land lay beyond the horizon. These clues weren't written down at first. They were passed through experience, sailor to sailor, voyage to voyage. Over time, these instincts were recorded and studied, turning observation into method. For ancient Chinese sailors, nature wasn't an obstacle. It was a partner, whispering directions to those who knew how to listen. Fact 60. Their maritime manuals were among the first detailed navigation handbooks in the world. The tradition of Chinese seafaring wasn't just built on experience, it was documented in remarkable detail. By the time of the Song and Ming dynasties, navigators had compiled maritime manuals that ranked among the world's earliest and most sophisticated navigation handbooks. One famous example is the Jinan Zhenjing Compass Classic, which described how to use the magnetic compass, interpret star positions, and follow wind directions across different seasons. Another was the Shunfeng Jiang Song, Fair Winds for Escort, a detailed record of sailing routes that covered everything from port distances to dangerous reefs and favourable winds. These manuals turned navigation into a teachable science. Young sailors could learn routes by studying the recorded experiences of those before them, turning instinct into structured knowledge. It's astonishing to think how modern their approach was, combining data, observation, and practice. Centuries before the word navigation even existed in most languages. Through these manuals, Chinese maritime wisdom didn't just survive, it spread. And it remains a powerful reminder that some of the greatest voyages in history began not with luck, but with careful notes, steady hands, and the courage to sail into the unknown. Fact 61. Polynesians were expert wayfinders. Long before modern tools, long before compasses, maps, or GPS, the Polynesians mastered one of humanity's greatest feats, navigating thousands of miles of open ocean, using only the natural world as their guide. These seafarers travelled vast distances across the Pacific, linking islands scattered over millions of square miles. They sailed from Hawaii to Aotearoa, New Zealand, from Tahiti to Rapa Nui, Easter Island, forming one of the most extraordinary navigation networks in history. Their knowledge, passed orally through generations, was based on keen observation. The stars, winds, currents, clouds, and wildlife all formed a living map. To them, the ocean wasn't empty. It was full of signs, rhythms, and patterns waiting to be read. Polynesian wayfinding wasn't just skill. It was culture, science, and spirituality combined. It proved that human ingenuity could thrive even in the world's most challenging frontier, the open sea. Fact 62. They used star maps memorized as chants and songs. In Polynesian navigation, the night sky was both chart and compass. But instead of drawing maps on paper, navigators memorized star maps through chants and songs, an oral code that preserved astronomical knowledge for centuries. Each chant described the rising and setting points of key stars along the horizon, forming star paths that guided voyages between islands. By knowing where each star appeared and disappeared, navigators could maintain a steady course across thousands of kilometres of ocean. These songs weren't just practical, they were poetic, weaving together navigation, mythology, and heritage. Every voyage was a living classroom, where apprentices learned to feel direction through rhythm and repetition. By committing the cosmos to memory, Polynesian wayfinders transformed the sky into a story they could sing, one that led them home every time. Fact 63. Ocean swells and wave reflections helped them sense nearby islands. Even when clouds hid the stars, Polynesian navigators still knew where they were. By reading the language of the sea itself, they could detect subtle differences in ocean swells and wave reflections, patterns created when waves bounced off unseen islands or reefs. By feeling these changes through the motion of their canoe or the slap of water against the hull, they could sense land long before it was visible. Experienced navigators described how certain cross-swell patterns signalled the presence of islands over the horizon. These sensations were memorized, not measured. The sea's rhythm became as familiar as a heartbeat. This deep connection between human perception and the natural world turned the vast Pacific into a navigable highway, one read not by sight, but by touch and intuition. Fact 64. They could detect land by observing bird flight patterns. For Polynesian voyagers, birds were among the most reliable signs of nearby land. They studied bird flight patterns, knowing that many species, like terns and frigate birds, travelled out to sea during the day but always returned to land by evening. Navigators would release trained birds from their canoes at dawn and watch their direction of flight. If the birds flew off purposefully and didn't return, it meant land was close in that direction. If they circled back, the sailors knew they were still far from shore. Observing the number, species, and flight height of birds also provided clues about how close land might be. This simple but ingenious method was often the final confirmation after reading stars and swells. To Polynesian navigators, every creature of the sky was part of their compass, a living arrow pointing the way home. Fact 65. Polynesian canoes were engineered for both speed and stability. The vessels that carried Polynesians across the Pacific were marvels of design. Double-hulled canoes built for speed, strength, and balance. Each canoe had 2 hulls connected by crossbeams, providing stability in turbulent seas. The design reduced drag while distributing weight evenly, allowing the ships to carry people, animals, and cargo across immense distances. Their triangular sails, made from woven pandanus leaves, could catch even light winds, while their shallow drafts made beach landings easy. The entire structure was crafted without nails, just rope, wood, and perfect engineering born of experience. These canoes weren't just transportation, they were expressions of unity between humans and nature. They symbolized movement, exploration, and connection, the very spirit that allowed Polynesian culture to spread across an ocean larger than all the world's continents combined. Fact 66. Navigators trained for decades to read the ocean's behaviour. Becoming a Polynesian navigator was not a short journey. It required decades of observation, apprenticeship, and experience. The ocean was their classroom, and nature their only textbook. Trainees learned to interpret the most subtle cues, the rhythm of swells, the flight of birds, the feel of wind, even the taste and temperature of seawater. They memorized how each island altered local wave patterns, and how different cloud shapes could reveal hidden atolls. Instruction was entirely oral and practical. A master navigator, called a pibato, would take apprentices on countless voyages, teaching through repetition until their instincts became as sharp as their senses. By the time a student graduated to navigator, they could sail across thousands of miles of ocean with nothing but their mind as a compass. It was the ultimate mastery of natural knowledge, earned not through books, but through generations of lived experience. Fact 67. The Polynesian stick charts represented wave and island patterns. Among the most fascinating tools of ancient navigation were the Polynesian stick charts, crafted from thin coconut ribs and shells. These charts, originating from the Marshall Islands, visually encoded ocean swells, currents, and island positions. Each stick represented a current or wave pattern, while shells marked islands or key reference points. The intersecting lines formed a geometric representation of how waves interacted with landmasses, but these weren't maps meant for constant reference. They were teaching tools. Navigators memorized them on land, internalizing the complex relationships between ocean patterns before ever setting sail. Once at sea, the charts stayed ashore, because true navigators carried them in memory. These ingenious models proved that Pacific Islanders understood the ocean not as chaos, but as an ordered, readable system, centuries before modern oceanography existed. Fact 68. The double-hulled canoe allowed safe travel across thousands of miles. The Polynesian double-hulled canoe, or waka, was the key that unlocked the entire Pacific Ocean. Its design was revolutionary. 2 hulls joined by crossbeams, forming a stable platform capable of carrying large loads and surviving rough seas. Unlike single-hulled boats that could capsize easily, the twin structure balanced perfectly against rolling waves. The canoes could reach impressive speeds, powered by triangular or crab claw sails made from woven leaves. Each vessel was carefully crafted using local materials: breadfruit wood, coconut fibre, and resin, with every joint lashed tightly rather than nailed. The result was a strong yet flexible ship that moved gracefully with the ocean's motion. With these canoes, Polynesians explored and settled islands thousands of miles apart, proving that ancient engineering could achieve what many once thought impossible: navigating the largest ocean on Earth with precision and safety. Fact 69. They navigated to Hawaii, New Zealand, and Easter Island centuries apart. The Polynesian Triangle, stretching from Hawaii in the north, New Zealand, Aotearoa in the southwest, and Easter Island, Rapa Nui in the southeast, represents one of humanity's greatest navigational achievements. Each journey was made centuries apart, yet all were accomplished using traditional techniques: no compasses, no maps, only memory and environmental knowledge. Archaeological evidence shows that these migrations occurred methodically. Sailors would explore, establish settlements, and maintain contact across vast distances. These voyages weren't random drifts. They were planned expeditions guided by confidence in their navigational mastery. To cross this triangle meant traversing over 10 million square miles of open ocean, a feat that modern sailors still find astonishing. It stands as a testament to the brilliance and courage of Polynesian seafarers who turned the Pacific into a network of connected worlds. Fact 70. Their oral traditions preserved. Maritime science across generations. Polynesian culture ensured that no knowledge was lost through the power of oral tradition. Stories, chants, genealogies, and training songs preserved the details of navigation, astronomy, and seafaring in forms that could survive centuries without writing. These oral teachings encoded technical knowledge, such as which stars rose at specific horizons, how winds shifted with the seasons, or how to detect islands beyond sight. Masters passed this wisdom to apprentices through storytelling, repetition, and lived experience. Some chants were mnemonic systems, poetic, rhythmic records of wave directions, star paths, and sailing instructions. Others described ancestral voyages, connecting the act of travel with cultural identity. Through this living science, Polynesian knowledge endured despite colonization, storms, and time. Today, the revival of traditional wayfinding continues across the Pacific, proving that this ancient wisdom still guides those who look to the stars and the sea. Fact 71. Arab sailors mastered Indian Ocean navigation. During the Abbasid era, Arab sailors turned the Indian Ocean into a vast network of trade and exploration. Their routes stretched from East Africa to India, and as far as China, long before the great European voyages began. They mastered the ocean not through chance, but through a deep understanding of monsoon winds, stars, and coastal geography. Every journey was carefully timed with the seasons. They knew when to sail east with the summer winds and when to return west before the storms. The Abbasid ports of Basra, Siraf, and Aden became gateways between worlds, places where sailors, scholars, and merchants exchanged not only goods, but ideas. Navigation was seen as a learned craft, and Arab mariners became known for their precision and reliability. What made them remarkable wasn't just their sailing skill, it was their ability to connect continents, spread knowledge, and blend the scientific with the practical. In their time, the Indian Ocean truly became the centre of the world. Fact 72. They refined the astrolabe for maritime use. Long before compasses became common, Arab sailors turned the astrolabe, originally a scientific and astronomical tool, into a powerful instrument for sea navigation. The device, a disc marked with celestial coordinates, allowed sailors to measure the height of stars or the sun above the horizon. With that data, they could determine their latitude and maintain a steady course, even far from land. It wasn't invented by Arab scholars, but they perfected it, simplifying its design for practical use at sea. They made it sturdier, easier to read under rough conditions, and more reliable for quick calculations. Using the astrolabe, navigators could pinpoint their position with surprising accuracy, transforming long-distance travel from guesswork into a science. This innovation would later influence European navigation during the Age of Discovery, but its true refinement began under the steady hands of Arab mariners. Fact 73. Latitude was measured. Using the altitude of the pole star. One of the simplest yet most brilliant techniques used by Arab sailors involved the pole star, the bright northern light that hardly moves in the night sky. By measuring how high it appeared above the horizon, sailors could determine how far north or south they were, a method that gave them consistent latitude readings long before modern instruments. They used everything from a polished wooden board to their own outstretched hands to estimate the star's altitude. Over time, they developed mathematical tables that correlated those angles with precise geographical locations. This was especially crucial in open waters like the Arabian Sea, where land was often out of sight for days. The pole star became their silent guide, a constant point of reference in a world of shifting waves. It's astonishing to think that something so simple, a single star, could guide entire civilizations safely across thousands of miles. Fact 74. They wrote detailed pilot books called Rahmani. To keep their knowledge alive and accurate, Arab sailors compiled pilot books, known as Rahmani. These were essentially handbooks of the sea, filled with sailing directions, star positions, distances between ports, wind patterns, and coastal descriptions. Each Rahmani was both a scientific manual and a personal logbook. They combined mathematics, observation, and experience, written in poetic yet practical language. A navigator could consult one to plan a route from Aden to Calicut, or from Muscat to Zanzibar, confident it contained generations of wisdom. These books weren't static. They were updated as new discoveries were made, reflecting a living body of navigational knowledge. Through them, Arab mariners passed their expertise from one generation to the next, ensuring that their mastery of the Indian Ocean would never fade. Fact 75. Ibn Majid, the famous navigator, documented star-based routes. Among all Arab navigators, Ahmad ibn Majid stands out as one of history's great seafarers. Born in the 15th century, he compiled his vast knowledge into detailed works that described not only routes and ports, but also the positions of stars used for navigation. Ibn Majid's writings, such as Kitab al-Fawaid fi Usul Ilm al-Bahr wal-Qawaid, Book of Useful Information on the Principles and Rules of Navigation, combined poetry with science, a blend that made technical information easier to remember. He described how sailors could use the rising and setting of specific stars to orient themselves on open seas, and how to adjust their bearings with seasonal changes. His texts became standard references for Indian Ocean sailors for centuries. More than just a navigator, Ibn Majid was a teacher who helped preserve centuries of maritime wisdom. His legacy stands as proof that long before modern technology, human skill, patience, and observation could make the world's greatest ocean feel like home. Fact 76. Arabs connected Africa, India, and China. Through sea trade centuries before global trade routes were charted on maps, Arab sailors were already linking the coasts of Africa, India, and China through an intricate web of sea routes. These weren't random voyages. They were carefully planned circuits following predictable monsoon winds that carried ships eastward in summer and back westward in winter. Ports like Aden, Calicut, Mogadishu, and Guangzhou thrived as crossroads of cultures. From Africa came ivory, gold, and spices. From India, textiles and precious stones. From China, silk and porcelain. Arab traders acted as the connecting bridge, the middlemen of the ancient world. But it wasn't only goods that travelled. It was ideas, mathematics, art, and technology. The sea routes became moving threads of civilization, woven together by sailors who could read the stars as fluently as they could read the tides. By mastering the rhythm of the ocean, Arab navigators helped shape one of the earliest versions of globalization. Fact 77. They named many stars still used in Western astronomy. When you look at the night sky and recognize names like Aldebaran, Altair, Betelgeuse, or Vega, you're speaking remnants of Arabic, echoes of ancient astronomers and navigators who mapped the heavens with astonishing precision. Arab sailors and scholars named hundreds of stars, cataloguing their positions and brightness. Their star charts were practical tools at sea, but also scientific documents that passed into later cultures through translation and teaching. Many of these names entered Western astronomy through medieval scholars in Moorish Spain, who translated Arabic works into Latin. Over time, the language of the stars became global, and even today, much of it carries the imprint of early Arab navigation and astronomy. These weren't just poetic names, they were coordinates of survival. Each star told sailors where they were, when to turn, and how to find home again, glowing markers of an invisible highway across the night sky. Fact 78. The Qibla compass influenced later. Navigational compasses, the Qibla compass, originally designed to find the direction of prayer, played a surprisingly important role in the evolution of navigation. Arab scholars adapted the magnetic compass for geographic orientation, marking not only sacred directions but also cardinal points and degrees of bearing. By the 12th century, these instruments had become more than religious tools. They were practical aids for travellers, explorers, and mariners. The adaptation of this technology revealed a deep understanding of magnetism and spatial measurement, long before compasses became standard equipment on ships. When this knowledge spread westward through trade and scholarship, it influenced the design of European navigational compasses. What began as a simple device for finding one's spiritual orientation became a key to unlocking the physical world's vastness. Fact 79. Their knowledge spread through Moorish Spain into Europe. Arab science didn't stay confined to the East. Through Moorish Spain, it flowed into Europe, reshaping navigation, astronomy, and geography. In cities like Córdoba and Toledo, scholars translated Arabic texts on astronomy and navigation into Latin. These translations introduced European sailors to the use of the astrolabe, star tables, and detailed sailing instructions that Arab mariners had refined over centuries. This exchange laid the groundwork for the later age of exploration. When Portuguese and Spanish sailors set out to map the world, they relied heavily on tools and techniques inherited from Arab traditions. So in a sense, every voyage westward toward the unknown also carried a piece of Eastern wisdom, the legacy of centuries of observation, calculation, and seafaring mastery. Fact 80. Arab sailors identified wind systems, such as the trade winds. Long before meteorology became a science, Arab sailors had already charted the patterns of global wind systems. They noticed how certain winds, like the monsoons and trade winds, blew steadily in predictable directions at specific times of the year. This knowledge wasn't theoretical, it was born of necessity. They learned to set sail when winds favoured them, and to wait out the seasons when the air turned hostile. Through observation and oral transmission, they built a mental map of the world's atmosphere. Arab navigators gave these winds names, studied their rhythms, and used them as dependable companions across the open sea. Their understanding of these systems turned vast and unpredictable waters into manageable, almost familiar routes. Their wisdom proved timeless. The same winds that carried their dhows centuries ago are still the ones that power ships today, silently reminding us of the sailors who first learned to harness the breath of the earth itself. Fact 81. The Vikings used sunstones to locate the sun on cloudy days. Imagine sailing across icy northern seas, the sky blanketed by clouds, and the horizon swallowed by mist. No compass, no map, just intuition and skill. Yet the Vikings found their way. One of their secret tools was the mysterious sunstone, a crystal that could locate the hidden position of the sun even when it wasn't visible. Scientists believe these were pieces of Iceland spar, a form of calcite that polarizes light. By rotating the crystal until light intensity matched on both sides, a navigator could pinpoint the sun's direction. It was like holding a natural compass in the palm of your hand, long before magnetism was understood. This innovation gave Viking sailors a powerful edge. It allowed them to maintain course across the fog-bound North Atlantic, reaching distant lands like Greenland and Vinland, modern-day Newfoundland. For people who face some of the harshest seas on Earth, such a discovery wasn't just clever, it was vital. Fact 82. Viking ships followed the flight of ravens to find land. Before the invention of modern navigation, Vikings turned to nature itself for help, even to the sky's feathered travellers. On long voyages, they carried ravens aboard their ships. These birds were released periodically when sailors believed land was near. If the ravens circled the ship and returned, there was no land in sight. But if it flew straight in one direction and didn't come back, the crew followed its path, knowing it had spotted land. This simple yet ingenious method saved lives and guided expeditions across unknown waters. According to sagas, Flokki Vilgedarson, one of the earliest explorers of Iceland, famously used 3 ravens to lead his ship there, earning him the nickname Hrafna Flokki, or Raven Flokki. The Vikings trusted their instincts and the creatures of the wild, proving that sometimes the best tools of navigation are the ones nature provides freely. Fact 83. They memorized coastal shapes and wave directions. Viking navigation was built on memory, observation, and intuition. Every experienced sailor could recognize coastlines not from maps, but from the contours of distant mountains, the color of the water, and the pattern of waves reflecting off unseen shores. They understood that the ocean had a language, subtle cues in its motion and color. Long before charts were common, these seafarers built mental maps so detailed that they could sail for days and still know exactly where they were. Each voyage added to a collective memory passed down orally. The direction of waves, the behavior of birds, and the taste of the wind were all clues. For the Vikings, navigation wasn't just a skill, it was a kind of sensory art, honed through generations. Fact 84. The Norse also relied on oral route descriptions called sailing directions. Written maps were rare in the Viking world, but oral navigation instructions known as leiðarvísir or sailing directions served as guides for mariners. These were detailed verbal accounts describing every part of a journey, how far to sail, what landmarks to expect, where currents shifted, and which islands marked the turning points. Passed down through generations, these directions became the Viking version of a nautical chart, living, evolving, and rooted in experience. A leiðarvísir might describe how to travel from Norway to Greenland, telling of stars to steer by, winds to wait for, and hazards to avoid. Each phrase condensed centuries of seafaring wisdom into a few lines of poetry-like rhythm, easy to memorize and repeat. It's through this oral geography that the Norse connected their scattered world, one story, one voyage, one coastline at a time. Fact 85. Medieval Europeans used the magnetic compass. After the 12th century, the magnetic compass arrived in Europe around the 12th century, most likely through trade with China or the Arab world. At first, it was a simple device, a magnetized needle floating in water or mounted on a piece of wood, but it changed everything. Before the compass, sailors had relied mainly on stars, wind, and landmarks. With this small tool, they could find direction even in fog or darkness. Navigation became more predictable, and long voyages safer. European mariners quickly adapted the compass for ocean travel, combining it with new maps and portolan charts. It wasn't perfect. Magnetic variation caused confusion at first, but it allowed medieval explorers to venture farther than ever before. The compass turned uncertainty into direction. It bridged the gap between ancient intuition and modern navigation, a quiet revolution born from centuries of observation and shared discovery across civilizations. Fact 86. Portolan charts revolutionized coastal navigation. When the first Portolan charts appeared in the late Middle Ages, they completely transformed how sailors understood the sea. These weren't artistic sketches or mythical maps filled with monsters. They were practical tools designed by navigators for navigators. Drawn on vellum, Portolans showed coastlines with remarkable accuracy, including harbours, reefs, and compass directions radiating from windroses. Sailors could finally trace routes from port to port using straight lines that matched real compass bearings. Every chart was the product of generations of observation. Mediterranean pilots recorded bearings, distances and landmarks, and cartographers wove those fragments into coherent maps. For the first time, mariners could see their world with precision, not imagination. These charts became the standard for centuries, guiding ships from Genoa to Alexandria, from Lisbon to Constantinople. In a world where the sea once seemed endless and uncertain, Portolan charts gave sailors something priceless: confidence. Fact 87. Mariners' astrolabes measured star height for positioning before GPS or even modern maps. Sailors looked to the heavens for their coordinates. The mariner's astrolabe, adapted from earlier astronomical designs, became their essential tool. Made of heavy brass so it could resist the wind at sea, the astrolabe measured the altitude of a star or the sun above the horizon. With this angle, a navigator could calculate their latitude, a revelation for anyone crossing vast oceans. To use it, a sailor held the instrument steady, sighted a star through the alidade, a rotating arm, and read the degrees marked along the rim. The small measurement told them how far north or south they were from the equator. It took a steady hand, a sharp eye, and calm seas, but the astrolabe turned the night sky into a reliable map. For centuries, it was the symbol of precision, a fusion of mathematics and seafaring intuition. Fact 88. The cross-staff and backstaff followed soon after. As navigation evolved, so did the tools. The cross-staff, introduced in the 15th century, simplified the process of measuring star height. Sailors held a wooden staff to their cheek, sliding a crosspiece until the sun or a star aligned with the horizon. The distance between the 2 points determined their latitude. While effective, it had one serious drawback. The observer had to stare directly at the sun. The solution came in the 16th century with the backstaff, which allowed navigators to take the same measurement with their back to the sun, using shadows instead of direct light. These instruments represented the transition from rough estimation to real accuracy. They were small, portable and practical, the working sailor's laboratory. Each refinement brought explorers one step closer to mapping the world with confidence and precision. Fact 89. Early maps were often symbolic rather than geographically accurate. Before scientific cartography, maps were expressions of imagination as much as observation. Medieval maps, especially Mappe Mundi, placed cities, rivers, and continents according to religious or mythic importance rather than scale or distance. Jerusalem often sat at the centre. East pointed upward. Distant lands were filled with drawings of strange creatures or legendary people. These maps were not navigation tools. They were worldviews on parchment. It wasn't that people didn't care about geography. It was that the purpose of a map wasn't yet to measure, but to illustrate meaning. Only with the rise of trade and exploration did accuracy take precedence. By the time Portolan charts and later globes appeared, the old symbolic maps began to fade, replaced by something new, a vision of the Earth grounded in observation, not imagination. Fact 90. By the Renaissance, celestial navigation had become a precise science. By the time of the Renaissance, navigation had become a true science. Sailors, astronomers, and mathematicians worked together to refine the art of finding one's place on the planet using the stars. Improved instruments like the astrolabe, cross-staff, and later the sextant made celestial readings faster and more reliable. New astronomical tables provided exact positions of stars and planets. Mathematics, especially trigonometry, gave sailors the formulas to translate those readings into latitude and eventually longitude. Navigation schools emerged in coastal cities, teaching mariners how to combine observation with calculation. Voyages grew longer, safer, and more ambitious. The Renaissance turned stargazing into science, transforming ancient intuition into disciplined skill. What began as wonder at the night sky became the foundation for exploring the entire Earth. Fact 91. Ancient navigation made possible global trade and cultural exchange. Long before modern shipping lanes, ancient navigators opened the world's first trade routes. By mastering winds, stars, and tides, they connected continents, linking the ports of Africa, Arabia, India, and China in a vast network of exchange. Spices, silk, and gold moved across oceans, but so did ideas, languages, and beliefs. Religion, astronomy, and art spread from one shore to another with every voyage. The sea became not just a highway for goods, but a bridge between civilizations. Navigation was the invisible force behind cultural fusion, the quiet art that made the ancient world global. Fact 92. It laid the foundation for cartography and geography. Every ancient voyage left behind more than footprints, it left knowledge of the earth. As sailors recorded directions, coastlines, and distances, they laid the groundwork for early cartographers and geographers. Greek thinkers like Eratosthenes calculated the Earth's circumference using shadow angles. Indian, Arab, and Chinese scholars mapped stars and coastlines with remarkable accuracy. Each new discovery refined humanity's image of the world. Without ancient navigation, there would have been no maps, no atlases, no global perspective. Every chart, from parchment to satellite, began with a sailor looking out to sea and wondering what lay beyond the horizon. Fact 93. Star-based systems evolved into modern celestial navigation. The same stars that guided ancient sailors continue to guide ships today. Early navigators memorized constellations and rising points of stars. Later, mathematicians turned those observations into celestial formulas. By the Renaissance, seafarers could measure angles between stars and the horizon with instruments like the sextant, translating starlight into coordinates. What began as intuition became science. Modern celestial navigation, still taught to naval officers, is the direct descendant of those ancient star-based systems. The heavens, once a mystery, became a map. Fact 94. Ocean current maps came from ancient route observations. Before satellites tracked sea currents, sailors sensed them with their own hands. Ancient mariners noticed how waves, driftwood, and even seaweed moved in consistent directions. Over generations, they built mental maps of the ocean's rhythm. Arab traders spoke of the monsoon cycle. Polynesians read the ocean's pulse through swells. Europeans later charted the Gulf Stream and trade winds. These early observations, passed down through logbooks and stories, became the foundation of modern oceanography. The world's first current maps weren't drawn by machines. They were drawn in the minds of those who lived on the sea. Fact 95. The concept of latitude and longitude originated from ancient measurements. Centuries before GPS, scholars were already dividing the Earth by lines of latitude and longitude. The Greeks, led by thinkers like Hipparchus and Ptolemy, proposed a grid system to describe any location on the planet. Latitude came from measuring the sun's or star's height above the horizon. Longitude, far harder to determine, relied on time and celestial observation. Ancient astronomers and geographers refined these ideas over generations, giving future explorers the framework to map the entire globe. The concept that the world could be measured, mapped, and navigated precisely, that was humanity's first step toward mastering the planet. Fact 96. Ancient maritime empires grew through navigational mastery. The rise of the world's earliest empires often depended on one thing: the sea. Civilizations like the Phoenicians, Egyptians, Greeks, and later the Malays and Arabs built their power not only through armies or cities, but through their ability to navigate vast waters. Control of sea routes meant control of trade, resources, and influence. Maritime empires thrived by knowing the winds, reading the stars, and building ships that could cross entire oceans. Ports became centers of wealth, diplomacy, and culture, the lifeblood of ancient economies. In essence, navigation was not just a skill, it was the invisible empire builder that turned coastlines into kingdoms and sailors into pioneers of civilization. Fact 97. Many early navigational terms survive in modern languages. Our modern vocabulary still carries echoes of ancient navigation. Words like starboard and port trace back to the steering boards and harbours of the early ships. The word navigate itself stems from Latin, navis meaning ship and agere meaning to guide. Even in languages far apart, similar sea terms appear, proof of how navigation shaped culture and communication. From Greek kybernets, helmsman, origin of cybernetics, to Arabic Ramani, sailing manual, the language of the sea became the shared tongue of humanity's wanderers. When we say set sail or chart a course, we're unknowingly repeating phrases that have guided travellers for thousands of years. Fact 98. Ancient wayfinding inspired modern-day revival movements. Today, the art of ancient navigation is being reborn. Across the Pacific, Polynesian voyaging societies have rebuilt traditional canoes and revived the ancient techniques of wayfinding, navigating using stars, swells, and birds without modern instruments. These movements aren't just about history, they're about identity, memory, and respect for human ingenuity. The recreation of ancient voyages connects modern people with their ancestors' courage and knowledge. Wayfinding has become a living bridge, proof that the wisdom of the past can still guide the present, one wave at a time. Fact 99. Space navigation borrows principles from ancient star navigation. When astronauts steer through the cosmos, they use principles first practiced by ancient mariners. Space navigation relies on observing fixed points, in this case distant stars and pulsars, to determine position and direction, much like sailors once used Polaris or Canopus. Modern spacecraft carry star trackers, digital descendants of the sextant, which calculate orientation by comparing star patterns to onboard charts. The vastness of space, like the sea, offers no landmarks, only light. Every interplanetary mission echoes humanity's earliest journeys, proving that the logic of the stars still leads the way. Fact 100. Humanity's desire to explore, from sea to space, began with ancient navigation. The story of exploration is a single thread stretching from dugout canoes to deep space probes. What began with the first humans crossing rivers and coastlines evolved into global voyages and eventually journeys beyond Earth. Ancient navigation was the spark that ignited this endless curiosity. The same instinct that drew sailors across uncharted seas now drives explorers toward the stars. Each time we set out into the unknown, whether across an ocean or across galaxies, we honour the same timeless urge to discover, to understand, and to find our place in the vastness around us.